skin health awareness. Our intended users for this system is teenagers and young adults who often experience acne and want quick, reliable, especially who are in rural or undeserved areas. And the last one, anyone looking for basic skincare advice based on visible acne symptoms without needing a medical appointment. First, our system provides a prediction of the acne type based on an uploaded image. Next, the system will give advice based on user-reported symptoms, whether the acne is pain, itch, or burn. And the last one, system provide skincare recommendations such as treatment and product suggestions.
For the scope and limitation, first, acne type detection using image to upload a facial image, which is then analyzed to identify the acne type. For example, blackhead, whitehead, papules, pustules, nodules, and cysts. For educational content, offer brief explanation of each type acne and general prevention tips to raise awareness and support better skin health. Next, support SDG 3, Sustainable Development Goal 3, by promoting skin health, encouraging self-care, and raising yearly awareness of common acne condition. It empowers users to better understand and manage their skin, contributing to overall well-being. For limitation, first, limited image accuracy. Detection may be affected by classification of acne type. Next, limited skin condition focuses solely on common acne type. It does not detect other dermatological issues like eczema, rosacea, or fungal infection. Static recommendation rules. Skincare advice is rule-based and does not adapt dynamically to new research or individual skin reaction unless manual updated. Next, how recommendation based on acne type, the system help user effectively manage their skin condition, leading to healthier skin and preventing complication. Second, enhance mental well-being. The system address the psychological impact of acne by boosting users' self-esteem and associated with skin issue. Third, encourage healthy behaviors through education on skincare routines and lifestyle choice. The system promotes healthier habits, empowering users to take proactive steps in managing their skin health and overall well-being.
Next, for knowledge-based structure, we use rule-based system, which uses if-then rules based on user inputs, which are acne type and symptom analysis. Our system uses forward chaining method, which means the system begins with the user's known input, such as the and burn. It then applies a set of predefined if-then rules step by step to determine the most relevant skincare advice or action. For example, the forward chaining start with image, then end user symptoms, then applies matching rules and generates personalized acne care advice. So this is one of the example of forward chaining diagram based on these rule-based systems. So if acne type is cystic and symptom is burn and symptom is pain and symptom is itchy, means continuing all active skincare products, apply a calming barrier cream, and immediately consult a dermatologist as these combined symptoms may indicate severe irritation or infection. So for testing, I'm going to demonstrate our system. So the data is trained using Google's Teachable Machine. We have collect various data by capturing images from the internet. Then the data is pre-processed and labeled with acne types are whitehead, blackhead, cystic, fungal, pustule, papules, and also healthy. So 7 classes are trained with 30 image samples for each class. And from Teachable Machine, we export the model code and implement systems coding in Visual Studio Code by using Python language. So this is the coding. Okay, so when I run, it will show user interface like this. Okay, so it has upload acne image button, which user can upload their picture of their acne condition. Then user can select any symptoms, either pain, itch, or burn. And after that, user can click button diagnose to diagnose their skin. So for example, I upload this image. And then I select pain, itch, and burn. Then click diagnose. So the output shows the predicted acne type, which is cystic acne, confidence 100%, and advice discontinue all active skincare products, apply a calming barrier cream, and immediately consult a dermatologist as this. So I select another image. Okay, then I don't want to select any symptoms. And then click diagnose. So the output shows the predicted acne type is healthy skin, which means that this picture has no any conditioned skin, and confidence 100%. A simple skincare routine with gentle cleanser, moisturizer, and sunscreen to support long-term skin health. So that's all for our system demonstration. Thank you.
So thank you very much. Okay, so dah terlebih 10 minit tau. So which is I think not very good lah. Okay, that's the first thing. Second thing, want to ask one question. Just want to know which area of SGD that you want to target. Hello?
SDG 3.
SGD 3 tu apa?
Good health and well-being.
Okay, good health well-being. So is it you already you mentioned this thing in your report?
Yes, doctor.
Okay. Okay, so that's all my question. Thank you very much. Okay.
Thank you, doctor.
Okay, welcome. Okay.
Thank you, Doctor.
Welcome. Okay, so next we proceed with the next group which is yang ni tunggu dulu kejap saya later I will distribute the attendance for today. We proceed with the group 3. Chai Yijing, An Chayan, Hon Sin Yong, Natalie Tan. Okay, so proceed. 10 minutes.
So, good afternoon to Dr. Yacob and all my friends. We are group 2 and
Group 3 is
our we are group 3 and our system title is FruitWise, which is a fruit freshness classification system. And so let us introduce ourselves. I am Ang Chayan.
I'm Chai Yijing.
I'm Natalie.
I'm Ho Sin Young.
So for that, let us introduce our system. So our system key feature is to first we will identify the fruits into 6 types, which is apple, banana, mango, strawberry, orange, and guava. And we will classify the input fruit image for apple, banana, mango, strawberry, orange, and guava as fresh or rotten using deep learning machine model. And the system will display the confidence score indicating the certainty of the model of the prediction. And at last, it will recommend the action based on the classification of the fruit status. For example, when the fruit was rotten, it will give the advice for the storage of the fruits. This system is to support the SDG goals 2, which is the zero hunger. So I will pass the presentation to Yijing.
Good afternoon, Doctor and all my friends. So now I will present about the problem statement of our project. So the first problem statement is the difficulty in identifying fresh and rotten fruits causes a large amount of food waste because a consumer may not identify the freshness of the fruit accurately and they might throw it away. So it causes food waste. And second is the traditional ways of checking fruit freshness by touch or sight can be subjective and unreliable because different people, they have different perspective and feelings. And if they might identify wrongly the freshness of the fruit. And the third is the consumption of rotten or spoiled fruit can cause health risk. So now I will pass to my friends to present the next one.
So the objective of this system is for the precision food freshness classification, which is classify the food as fresh or rotten using deep learning accurately by AI to eliminating the subjective perspective by human, and provide storage and usage advice based on the type and condition of the fruit to avoid the food waste and to protect the health and safety of consumer. So this is because the advice of deposit the spoiled fruit properly can help to prevent the health risk by ensure consumer only eat fresh fruit to avoid the fruit waste.
And then next is a anticipated impact of this system. First one is the reduction in food waste through early detection. The users can make the informed decision about consumption and storage to minimize the food waste by classifying the fruits. Then the second one is increase the consumer confidence in food safety. User can gain confidence in the safety and the quality of the fruits they consume by relying on this system rather than their personal judgment. And the last one is to support for the local farmer and markets. They can prevent unnecessary waste of fruits and the financial loss due to the misjudgment on fruits appearance, like some like the one rotten or something like that. Next, I will pass to my next member to present her part.
Now I'll present about the future improvement. So what we can do to improve our system further in the future is to expand the fruit types. Because now we only have 6 types of fruits, so we can include a variety of fruits to increase the usability and inclusiveness of the system. We can also include multilingual support because now our system only uses English, so we can include other languages such as Malay, Chinese, and Tamil to reach more communities. And the last one we can do is to expand the freshness classification because our system now only has fresh and rotten as the classification. So we can add more detailed freshness levels such as unripe, not very fresh, or slightly rotten. So this can also increase more useful and practical advice for users. Next, Chayan will demonstrate our system.
Well, first we need to go to the directory. We save the project file, which is C file. And we run the file by Anaconda Navigator. So this is the main user interface of our system. So user can upload the image. We test with rotten strawberry first, and we can just click the button, and it will display the confidence level and the suggestion of the class based on this image. But we also offer a physical observation to user. When user click the physical observation they get, such as color is brownish, visible mode or spot, and then they click again the predict and suggest button, the confidence level of the rotten strawberry will increase, and it will give the advice based on the image. This apply the if then rules, which is forward chaining. So our setting is when more than three or more than 2, the confidence level will be the more than 2 physical observation that user click, the confidence level will be recalculated based on the user options, and the advice will be displayed. And we can test another sample, which is fresh apple, and then we predict and suggest. So they will came out the advice also. And rotten banana.
Okay, can I interrupt you?
Yes.
Okay, just want to know because you already testing the picture, right? So really query about, you want to say the system is able to detect the image and then can advise the user whether it safely consume or not,
Yes.
or is it consume or not. But I feel like the uh what we call say what's the things, I mean the option used for what? Because here, okay, because actually the system able to do the physical observation, why we need to have a option for the physical observation? This is the thing that I not really understand.
Because sometimes AI is not 100% accurately to detect the appearance of the image. So we can add this physical observation option is to ask this AI to more accurately identify the symptoms of the fruit, which either it is fresh or rotten.
Because when I see here, okay, yeah, I understand. Smell is so, of course, the AI cannot detect a smell. But however, color is brownish, feel to soft. Okay, that one AI cannot do it. Visible, visible more. Okay, so color is brownish, visible is small, and feel is wrinkle. Actually, the AI can do this thing. Uh, understand? So, so these are the things that happen. Okay, it seems like it's better you use the fruit physical option observation. No need to do the image processing. You can choose this thing. Understand?
Oh, because our class is based on the food type, which is the sample. The class has 12, which is 6 types of food. The first only collect the sample, which is classified as fresh or rotten. So we hope to tambah this physical observation option to help the prediction of the symptoms lah.
Okay, okay. Okay, so I accept the reason. Okay, so already the time's up, 10 minutes. Okay, thank you very much.
Thank you, Doctor.
Don't forget to
Thank you, sir.
submit your system and project at our Yellow portal. Okay, thank
Okay.
you.
Thank you, Doctor.
Yeah. Okay, next, without wasting a time, we proceed with the next group, which is group 6, Madana Vilashena Privita. Okay. So I start the timer. 10 minutes will be given. Group 6, Madana Vilashan, Sneha Privita. Okay, boleh start. Okay, masa berjalan. Hi, Madana. Do you having problem with the microphone? Anybody want to help Madana? Mungkin Sneha Privita can help your team member to figure out what's the problem.
Sorry, my line was problem, sir. Can I start, sir?
Yeah, sure. Sudah 1 minit sudah.
Sorry, sir.
Ah,
Good afternoon. My name is Privita and my teammate name is Neha and Madana. We are going to present about smart trash. Next slide, Madana. And our project introduction is about rapid urbanization and population growth have a lead to a surge in a waste, straining traditional waste management. The Smart Trash Classifier Expert System offer an AI and a sensor-based solution to automatically detect, classify, and sort waste, enhancing segregation accuracy, reducing human effort, and promoting eco-friendly disposal. And the problem statement is improper waste segregation lead to increased landfill usage, environment pollution, and poor recycling. And second is manual sorting is a time consuming, inconsistent, and process health risk to workers. Third is lack of intelligence. Automated system result in a low recycle rates and effective waste management. And last is a smart, efficient, and scalable solution is needed to accurately and autonomously classify waste. And our project objective is to design and develop an intelligent system which enable of automatically detect into a classify different types of waste. And second is to utilize sensor, image processing, or machine learning algorithm to improve the accuracy and efficiency of waste classification. Third is to promote proper wastage segregation at a source, therapy enhancing recycle rates and reducing environment impact. Fourth is to minimize human involvement in a hazardous waste sorting process.
Okay, for the outcomes, there are different outcomes for our system. So the first one is the smart trash classifier provides a simple interface for waste sorting. So the first one, we can see that there's item type, there's materials if it's chosen other, and then there's condition, and also there's two buttons which is classify and clear. So for the output, there are 5 types which are recyclable is the first one. So as we can see in this interface, it shows recyclable by choosing the plastic bottle and as the condition as clean. The next one. Okay, as for to get the next one, which is landfill, the item type should be choose aluminum can, and if it's dirty is chosen, so it classify as landfill. Next. For the third one, we can see is headers. So the problem is that we chosen battery and the condition is as dirty, it classify as this. Okay, next. Okay, the next one is for the compostable. So we have chosen food scraps and as clean, so it classify as this. Okay, next. The last one is cannot classify. So when I choose other and as rubber, and for the condition is clean, it doesn't classify because the material is not recognizable by the system. Okay, next. So now I'll pass to Madana for the demo.
Hello. Okay, now I'm going to present my demo. Can see my screen. Okay. Okay, so here we have the UI where we have to upload image. And then it has to show the confidence level. For example, so if we upload this image, if it is more than 0.50, it can launch the second UI. If it's less than 50, it won't open the second UI. But if we upload other than the image, it will show the error. Okay, so here we have different type of the materials. So if let's say I choose a cardboard and then we'll classify. So as recyclable, reasoning is clean cardboard is highly recyclable. So and the second one, if I put the dirty, so the dirty glass container cannot be recycled. And that the battery, hazardous reasoning batteries contain toxic metals take to hazardous waste facility. And then styrofoam, styrofoam is not recyclable. And lastly, if I put let's say the rubber, and then it cannot be classified. That's all.
Yeah, I have a question. Is it your system able to replace the human job?
Yeah, yes.
Because as we can see here, okay, how to say? Okay, you need to understand about the expert system. So expert system, basically we are mimicking whatever task expert doing. Okay, let's say you are doing about something that related with the recycle, and then you need to know what they are doing. So we give the uh the things to this expert, recycle expert, and then they classify the trash, right? And then
Yep.
when they classify the trash, and
Mm.
then after that they keep it on their store. Okay, so now it comes to the question, when you doing this thing, okay, when you're doing this thing, and then is it this thing able to replace the human job?
Yep, can.
So that's mean the human job can resign now.
Yes.
Because like this, actually this thing is visible. Okay, human
Ah,
as a user, normal user, we can see this thing. So what the purpose of the image recognition on this thing? Understand? Uh, understand?
Yeah,
But
yes, okay.
sir,
Understand? Okay.
so
Hmm.
for our system, as you can see that earlier he chose the cardboard, and then over there, the first diagram over the left, it shows predicted item earlier was cardboard, and then the second interface over here on the right, the item type, it follows what is in the picture, which means it reads from the picture. But then we still have a choice to choose the item type. That's the only thing. So, for example, now he choose plastic and it shows in the item type as plastic as well.
Okay. So the recommendation is whether recycle or not recycle.
Yeah, and
How about you?
recyclable type as well.
How about you just choose anything? I mean, maybe you use a image from, I don't know, image from the handphone. Is it possible?
Yeah, but unless the confidence level must be more than 50, so you can open the second UI. So if let's say if the handphone is made of metal, then it can the confidence is more than 50.
So that's mean your system can detect handphone.
Yep.
So try, cuba, tengok. Buat tak?
I think I
Ada
need to
datang?
download
Tak
the
ada.
image.
Okay, kalau tak ada tak apa, it's okay. Sebab we are already time's up 10 minutes.
Okay, thank you, sir.
Okay, thank you very much. Okay, now we proceed with the next group. So next group is siapa? Next group is group 7. No Arsila, Wan Najwa, Daniel Aiman.
Assalamualaikum sir, can we start now?
Yeah, so please proceed. Masa berjalan. 10 minutes
Okay.
only.
Alright, can you see the screen, sir?
Can.
Alright. Assalamualaikum to Dr. Yaakob and a very good day to everyone. We are proud to present our project called Big Breed Identification. First thing first, allow me to introduce our team member. My name is Nur Asila. Alongside with me are Hakimi and Najwa. Next slide. Okay, let's begin by understanding why our project is important. Firstly, pig identification this day is still done manually on many farms. This traditional method is time-consuming, prone to human error, and difficult to scale in large farm with a large population. And secondly, your tag and notches used for the identification of the pigs can be lost, damaged, or even misread, which leads to serious consequences like misidentification, inaccurate breeding decisions, and decline in meat quality and market value. This problem highlights the urgent need for automation and reliability in breed identification, especially in context of modern and sustainable farming. Next. Next slide. Okay. So what is our system purpose? First, our system trying to achieve an expert system to classify pigs into their type of breed using three categories, which is color, body shape, and ear size. After that, we want to provide a real-time and accurate breed identification to assist farmers and researchers in making informed breeding and management decisions. And thirdly, we wanted to support the sustainable agriculture practices by promoting biodiversity conservation, breed traceability, and responsible livestock management in alignment with SDG 15. And SDG 15 stands for Life on Land. Next, I pass to Najwa.
Next, system features. PBI, Pig Breed Identification Expert System, is designed to support sustainability livestock management and biodiversity preservation by automating the identification of pig breeds using a combination of AI-based image classification and rule-based reasoning with the help of Kaggle dataset, teachable machine, and Anaconda Navigator. Let me test my. First, I will select image. So it will appear Poland, China, class of the pig breed. Next, it is British Saddleback. We test based on the color of pig, ear, and also their body shape size. Next is Maysan Pigs breed. Next is a pig breed. And lastly, we have large white pig breed. That is the system testing. Next, I will pass to Kimi for the impact and future improvement.
For the impact of this expert system, it's that it can conserve biodiversity. So to support identification of rare or endangered pigs breed. Second, to improve breeding and farm management that can help farmers select breeds that match their farming goals. Thirdly, it also impact in educational and training tool, which is useful in agriculture education, veterinary programs, and training for new farmers. Lastly, it's also an innovation in smart farming, lays the foundation for precision agriculture, where AI tools guide decision from breed selection to feeding and healthcare. Next. For future improvement of this expert system, we can use integration with image classifiers and mobile apps to combine the rule-based system with deep learning image classifier to fully automatic identification. Secondly, we can use cloud-based knowledge sharing to host the system on the cloud platform, so breeders, researchers, and institutions can collaborate, update, and share breed data. And other future improvement is using fuzzy logic or probabilistic reasoning, generate data integration, breed performance analytics to monitor and compare growth rate, feed efficiency, and health record based on breed. And lastly, using multilingual and localized versions to translate the system for local communities and farmers to increase accessibility and adoption globally. That's all from our team.
Yeah, I have a question. The system just detect the peak, is it?
Yes, sir.
Detect category of peak without any suggestion.
Just based on the color of pig, ear shape and only body shape size.
And then categorize the peak. Good. Okay, so now we come to the question. So if you, let's say if you category the peaks, so because we are doing for we want to develop a expert system. So when we develop a expert system, so we need to know who is the expert here. So if we saying that expert is a farmer, okay, expert is farmer. So what they are doing, is it the system able to help them? Understand?
Understand, sir?
If not,
So,
you just make a extra work lah. You have a farmer, at the same time you have a system. The objective here is we develop a system so that the system can help the farmer at least, or maybe we don't need a farmer in the future. We just have a system only. I know it seems like not logic, but this is the motivation. The motivation behind expert system. You want to replace the human, right? For me, actually, you are lacking in terms of the suggestion here. Okay, let's say like this: breed classification, and then detect. You can detect. Okay, so this is a British bag, and then give a suggestion. Okay, for example, maybe you can suggest. Okay, if you this one is how much per kilo, or maybe this one is what kind of the suitable recipe, for example lah, suitable recipe for cooking. Contohnya lah. So the expert that you want to replace here is actually is a salesman. Nampak tak sini?
nampak, sir? Faham.
If you just classify, so it seems like you akan redundant lah. Betul tak? Kalau you replace macam you tambah suggestion, and then benda tu dia macam, it seems like it can help the farmer itself. So because the farmer alone, we need to ask them, okay, this one is what, and this one is how much, and this one is suitable for what? I mean for cooking, for example, I don't know. So maybe the farmer, standalone farmer, he or she get headache lah on this kind of the question from the normal user. So if we come out this kind of the system, at least the system can help the farmers. And if we just categorize, so it not help the farmer at all. The user still ask the farmer again, right? So this is me, but never mind. We already time's up. 10 minutes. Okay, thank you very much. So for presenting, okay. So I appreciate it what you have here. Okay. Thank you.
Thank you, Dad.
Okay, so now we proceed with the next group. So next group is group 13, Sulaiman, Hussein, Faisal, Abdul Rahman.
Yes, sir.
Okay.
Can you hear me, sir?
Okay. Sure, sure.
Yes, Assalamu alaikum everyone and good afternoon. My name is Hussein and today I'm going to start with the introduction for our presentation. So our system is Safe Household Stuff Disposal Advisor and our group members are Abdurrahman, Hussein, Faisal and Sulaiman. Okay, next. So as we know, our homes contain a mix of everyday items like batteries, bottles, boxes, clothes, etc. that often end up in the wrong bin. So mis-sorting waste leads to pollution, resource loss, and health risks. Safe Household Stuff Disposal Advisor uploads a photo to instantly identify an item and tell you exactly where it belongs. Next. So why proper sorting of everyday stuff matters? So homes generate a wide variety of wastes like batteries, bottles, plastic that often all get tossed in one bin. So mixing recyclables, e-waste, textiles, and hazardous material leads to soil and water pollution, lost resources that can be recycled, and safety risks for sanitation workers. So now I will leave you with Sulaiman for the next part of the presentation.
So our project stands on 4 clear objectives, each one building with the last. So firstly, we have the detect. The system must reliably detect the household stuff items from a single image. And secondly, we have advice. So it must advise the correct disposal method instantly, so user don't waste time searching guidelines. And thirdly, deliver. We will deliver a lightweight desktop GUI built with the Tkinter and TF Lite. And finally, we have ensure. So we will ensure explainability. A rule engine shows the regulation behind every recommendation, so user trust our advice. Next. So who benefits? So we have homeowners and renters. They just want confidence that today's trash goes in the right bin. And we have also parents and students. So this will be perfect for class project. Kids snap a picture lane and form a good habit early. Community recycling and coordinators, they can deploy the apps at drop-offs to cut contamination rates and feel fewer where does this go questions. So now we'll pass it to Faisal.
So now moving to the expert system. For the expert system in our project, we have two. The first one is local waste, which can be like e-waste or chemical plastic or textiles, following the city published guidelines. The second expert system in our project is the manufacturer instructions, which is labeling for chemicals, like for example, bleach or paint, which is built into our rules. So next. So next, moving to the Sustainable Development Goals. The SDG that we target in our project actually is the responsible consumption and production, which is significantly reduce waste generation through prevention, reduction, recycling, and reuse, achieving the environmentally sound management of chemicals and all wastes throughout their life cycle. So moving now to Abdurrahman.
So in the model training, we use teachable machine. We use 7 classes to train our model. Several classes that we use a different number of images to train each class. Also, we use the advanced rules, main settings. Now I will move to the application. I will run the application of expert system, our application. Okay, we can import and upload an image into our system by clicking on this button. Then we can choose any of these classes to test the system. So I will choose the battery class. I will choose this image. Then I got the confidence of
100%, and then the system indicates that the trash type is electronic waste bin, sorry, and the system advises us to take the item to the e-waste drop-off. I will choose another class, which is maybe clothes. Let's say I will choose this image. So I got confidence of 100% also. The system indicates that the trash type that we need to use is textile recycling, and the system advises us to donate wearable items. So if the item is not wearable, we need to textile recycling for textile recycling the item. For other classes, we have like paper, plastic, or also shoes. Let's say I will choose this one. I got the confidence level of 99. The trash type the system indicates is show recycling and donation. The system advises us to donate usable shoes or recycle the not usable one. Other classes is, for example, paper. Let's say we'll choose this one. So the confidence level of this image is 99%. The system tells us to the trash type we need to put the item in is paper recycling. The advice is recycle with the clean paper, no food or grease in the paper. The last class is for plastic. Let's choose this one. So I got the confidence level of 99. The trash type is chemical plastic recycling. The system advises us to empty cap on and deliver to chemical plastic collection. This is our project. Now, we thank you about your listening to our project. Thank you. Excuse me, sir, do you have any questions?
Okay, so can proceed with the demonstration.
You mean, sir, I need to
demonstration? Oh, you already done the demonstration,
We
right?
already
yes.
done.
Yeah.
Okay, so I think there's no need to ask because your group member already asked me this morning. So I don't know
Yes.
what kind of the question need to ask. So okay.
Okay, thank you, sir.
But the thing is okay, I think I can accept lah. Okay, thank you very much.
Thank you, Doctor.
Yeah, thank you. Okay, so we proceed with the next group. So next group is group group 14. Kritigan, Parthiban, Ganesh.
Yes, sir. Is the slide visible, sir?
Okay, visible. So I already turn on the timer. Masa berjalan. Okay, 10 minutes only.
Okay, we got introduction. Okay, so we do fruit freshener classifier for our project. So my name is Parthiban Subramania. My metric number B03231079. This is our team, Uganesh and Kirtigan. So first of all, introduction. Also, fruit waste, especially of fruit, is a growing concern. Many consumers throw away fruits too early because they are unsure whether the fruit is still good to eat or not. Slight bruising and softener is often mistaken as a spoilage fruit. To address this, we have developed the fruit freshener advisor, which is our system, an expert system that mimics human reasoning to access fruit freshness and recommend actions. The system promotes sustainable consumption, directly supporting the UN Sustainable Development Goal, which is SDG 12. So, from me.
All right, sir. As for the problem statement, so every day countless fruits are thrown away not because they are spoiled, but because consumers simply aren't sure if they are still good to eat. So minor imperfections like bruises or color changes often lead to premature disposal. So this happens not due to negligence, but due to the lack of expert knowledge at home. So right now, there's no accessible tool that can help people accurately assess fruit freshness. So this leads to unnecessary food waste, higher household costs, and contributes to environmental strain. So we saw a need of smart, user-friendly system that can guide consumers with clear, reliable advice on whether to eat, preserve, or discard their fruits. So our solution aims to empower households to make informed decisions, reduce waste, and promote responsible consumption.
So the objective, build an expert system to evaluate fruit freshness, provide advice, eat now, store, cook, or discard, design a user-friendly interface for consumers, and encourage suitable food habits in household. So this is the outcomes. So first, the user upload an image of a fruit. The AI then process to this image and identify the fruit types. As seen in the example, the AI classify the fruit as carambola, as star fruit, with a high confidence level of 0.84, indicating a strong degree of certainty in its identification. After the AI classify the fruit, the user is prompted to provide additional details about the fruit. These include information such as skin color, texture, smell, visible mold, bruises, and whether there's leaking juice. These details help the system make a more accurate assessment of freshness. Once all the details are entered, the user click check freshness. The system then process this information and details the freshness result. In this particular example, the carambola is determined to be ripe, and the advice given is to eat now or refrigerate. So this one, the results shows spoiled, and the advice given discard immediately due to leakage. And this one, the result is overripe, and the advice given is to use for baking or smoothie.
All right, so next will be the demo presentation. So as we can see here, this is our UI for fruit freshness classifier. So we use teachable machine to train our class model, and then as for the example, let's say I upload a image. So these are the collection of images that we have. So let's say I choose banana. So I upload the image. So as we can see, the banana has been detected with the confidence level of 0.96. So if the banana has a lower confidence below 0.8, the fruit details UI will not be shown. So if it is 0.8 and above, it will prompt the user to add additional details such as like skin color. So for this banana, let's say I put yellow as for skin color, then texture soft, wait. Then visible mole, no. Bruises, yes. And then leaking juice is no. So if we check for freshness, we can get the status right and advise to eat now or refrigerate to extend shelf life. So that is for banana. And then let's say I want to change the fruit details over here. Yes, sir.
Question.
Yes,
Sorry, I
yes,
have a
yes.
question. Sorry for interruption. Because
Problem.
just really confused what the purpose of you uploading the image,
Mhm.
and at the same time you need to enter the fruit details. What the purpose of that? Because the system, I mean the image processing able to detect the types of the image, right? For example, you upload the banana, so why you need to key in banana again? And also able to detect the skins also and this color. Okay, unless it cannot detect a smell, yes. And then other thing is a smell. What is the meaning of the smell is sweet? Sweet ni maksudnya manis kan? So smell ni which is we use the nose. How we can smell sweet?
Contohnya dia macam smell dia manis, macam
Macam
like
mana smell
if
manis? Understand. Kalau sweet ni kita guna, we use our tongue to feel it, right? But smell ni we use our nose. Selalunya busuk, wangi. Betul.
so yes, I agree with you, sir. But so let's.
Wow, I really cannot understand smell. Okay, other thing is a visible mole. Actually, visible we can do the image processing also. Bruise also. Leaking juice, yes, we can use it. So here you just no need to enter the details. You just texture only because texture image processing can do that. Texture and smell also wrong. If not, what is the purpose of you the image processing?
Right, sir. So as for the fruit name, it will be detected using the AI system. Just for the skin color, texture, and smell, the user have to input it manually.
Upload. Please
All
upload
right.
again. I want to
All
see.
right. So let's say it's
Watermelon.
watermelon. All right. So watermelon. So as we can see, okay. So as we can see, the fruit type is watermelon. So actually, user can't change this. User just have to upload the image. So it will detect using AI system. So
And then
as for
skin
skin,
color?
okay, skin color. Let's say I put
Why you need to enter manually?
so skin color we have to enter manually because like let's say the fruit is not it's unripe, so unripe fruit has different color and so on. So we chose to we give it to the user to
No,
select the skin color.
I
So
mean
on.
you need
Yes.
to actually you can add the class for the green, green, yellow, right? You just the thing is here in the green training you just do the class watermelon only. You didn't do the class for the green.
Yeah.
Actually, you can do that, but however you didn't do, so that's why you need to enter manually. Can so it's like a double work here. Can.
Yes.
Okay. So so this is your ni lah. I know the weakness of your system. Okay, I want to know. Now you already come up with the system. So who is the expert doing this thing? I mean, after the system are done, who is the expert that? I mean the expert task that you want to replace. Who will benefit this thing?
So okay, well, this thing will benefit mostly the housewives who yes, housewives. So they can use this system to whether to determine whether a fruit has to be preserved or has to be eaten immediately, or expected lifespan of the fruit they have in any households.
Previously, who doing this job?
For example, in my house, my mom was doing that. So yeah,
Yeah. Who is doing this job previously?
for example, in my house, so my mother will be doing all this sorting things and so on. So yeah, so it will maybe help her to classify more easily in the future. So
Your mother using this thing, categorize this thing, and then after that, this thing is benefit to the to the housewife. You see, okay, it should be you will replace the expert. So that's why I keep telling to my student, expert is about to replace the human. So that's me in the future. No human no need to work. So this is the motivation behind this thing. So if you put this thing at your home, but the housewife still need to do this job. So what the purpose of the system? The system should help the people, not burden the people. Is it? Right. Can.
Yes, sir.
Can. Okay. So time is up. Dah 10 minit dah.
Alright, sir.
Okay. Okay, thank you very much. Okay, Ganesh. Okay, thank you.
Thank you, sir.
Thank you, sir.
Okay. Okay, so we proceed with the next group. So next group is from group 20, Fuad, Ahmad Luman Hakim, Muhammad Niza, Ahmad Shukri. Okay, so I turn on the timer.
Can you
10
see
minutes from now. Okay. Can. Sure, proceed.
Assalamualaikum, sir. Can you hear my voice?
Can. Proceed.
Okay, alright. Assalamualaikum warahmatullahi wabarakatuh to Dr. Yaakob and all my friends. Today, our group will represent artificial intelligence, which is fabric defect detection expert system. First of all, let me introduce myself, Muhammad Nizar Rifaat, with my members Ahmad Luman Hakim, Fuad, and Ahmad Shukri. Next. Okay, for the introduction, before we go into the details of the problems, let's understand the background. The textile industry faces a serious challenge with fabric defects. These defects not only reduce product quality, but also lead to financial losses and material waste. This project addresses the issue by using artificial intelligence, and we create an automated expert system. The system is designed to detect defects in fabric image, helping manufacturers improve accuracy, efficiency, and overall quality control. This kind of AI integration brings innovation to traditional industries, helping them become more competitive and sustainable. So next is the problem statement. In current manufacturing environments, fabric inspection is mostly carried out manually by human workers. This process is not only slow, but it also varies based on the inspector's experience. So the inconsistent judgment can lead to different outcomes and affecting overall production quality. So there is no automated tool for defect identification during production. This will make the production issues are detected only after the post-production. So with this, it could save time and resources. Fabric waste and low customer satisfaction due to overlooked defects. So for the objectives, the main goal of this project is to leverage computer vision and machine learning techniques to classify and detect fabric defects in real time. This system can quickly, accurately identify issues, reducing reliance on manual inspections. So this also provide clear classification and explanation to the end user. This helps worker take appropriate corrective actions and build trust in the system's decision. This support Sustainable Development Goals, mainly Goal 12, that is responsible consumption and production. And this will be explained by my friend Fuad.
So our expert system project supports several SDGs. Firstly, SDG 12, which are responsible consumption and production. Our system detects fabric defects early in the production line. This helps reduce waste by preventing defective materials from being processed further or sold. It encourages more efficient use of raw materials, better quality control, and promotes sustainable textile manufacturing. Other than that, SDG 9, which are industry innovation and infrastructure, this system demonstrates how artificial intelligence can support innovations in traditional industries like textile manufacturing. By using image classification and expert reasoning, we bring smart technology into a conventional workflow, making it more intelligent and cost-effective. Lastly is SDG 8, which are decent work and economic growth. By automating the fabric inspection process, we reduce the need for repetitive and tiring manual labor. This allows human workers to take on more supervisory or technical roles, leading to improved job quality and higher productivity in factories. It also supports industrial modernization, especially for small and medium garment producers. In conclusion, our expert system demonstrates how artificial intelligence can improve fabric quality control through automated image classification. It provides fast, consistent, and informative results, helping users make better decisions with minimal effort. More importantly, it contributes to global sustainable development goals by reducing material waste, improving production efficiency, and promoting responsibility industry practices.
So let's start with continue with the testing. So So this is our program. We start it, fabric defect detection, and then we upload the fabric image. And then after that, we have certain classes of defect fabric, which is defect free, defect with a whole horizontal line, stain, and vertical. So this is an example of the data set. So we just, let's say we choose the lines, and then we take one example, and then we open. And then we click the classify fabric, and then we get the result. Class defect lines with confidence, and also what is the defect, and then also the advice. It indicates inconsistent tension, adjust machinery, calibration. So we can try another image, for example, the vertical defect. So we try to choose this picture, and then we upload. And then and then we classify the fabric, and then we can see is defect vertical, confidence level, fabric defect, and also the advice could be due to machine misalignment, inspect loom settings. And then we can try the final one, testing. For this example, let's say I try this image, and then classify fabric, and then is detect as defect free, which is true, free of defect, and then the advice no action needed, fabric is in perfect condition. So any questions, sir? Sir?
Hello, you.
Any questions, sir?
So far okay lah, no issue. Because just want to know what is the fabric status not be fake. No action needed. Fabric is perfect question. So I just want to know who is the expert people for the system.
Expert people is the someone who handle the QNC, which is quality checking in the industry that using the fabric product. So this can replace them and also enhance the loss of production in days and also detect the defect faster than the human.
So which SDG that you want to target?
We use SDG 12, which is SDG 12. Wait, SDG 12, which is responsible consumption and production. It helps reduce the material waste. Right.
Okay.
SDG 12.
Okay, thank you very much. Okay,
Alright.
so I think so this one is a good for me it's good because it really have a motivation for the expert system. So by using the system, so no need to worry about we need to hire expert people for this factory. No need to do that because the system able to replace them. So even though it's not perfectly doing all the tasks, but when we can see the system, so it able to detect the defect and it have a good suggestion whether this thing we should take it or use it this fabric or not. So seems like the system doing what actually the expert people doing. So that's why this system able to help the human to do the job or maybe can replace the human when doing the job. Okay, that's good. Okay, thank you very much. Okay, so
thank you, sir.
Welcome. So we proceed
you,
with
sir.
the next group. Next group is group 20. Group 22. Muhammad Nur Hafizi, Muhammad Amirul Arif, Muhammad Fikri, Muhammad Haziq. Okay, so I start the timer 10 minutes. Start from now.
Alright, Assalamualaikum and a very good evening. We are from group 22, which is our title is sports ball identification. Next. So our members, we have 4 members, which is Hafizi, and then Fikri, Amarul, and Haziq. Next. For problem statement, people often struggle to identify and differentiate sport balls, such as rugby balls, footballs, basketballs, and American footballs. The second problem statement is manual identification may lead to errors, especially in inventory, training, and retail settings. The last one is there is a need for a smart system that can analyze ball characteristic and suggest the correct ball type. So for objective, we have 3 objectives. The first one is classify balls based on input features, such as shape, size, texture, and so on. The second one is provide accurate and consistent ball identification. And the last one is assist users in making informed decisions in sports-related environments. Okay, for our system features, we have 3 system features, which is the first one is Kaggle dataset. Second one is teachable machine by Google. And the third one is the main features, which is Anaconda navigators. For the Kaggle dataset, we use the Kaggle dataset to gather sample data and features of different sports balls. And the second one is to provide structured information for building the knowledge base. And for the second one is teachable machine by Google. we used to train a basic image classification model for recognizing ball types. And then it allows real-time classification using webcam or uploaded images. And then for third features is Anaconda Navigator, which is we use Python environment manager, which is used to run and manage the AI system. And the last one is supports libraries like Pandas, NumPy, Skykit, Learn, and so on. Next.
Let's go through to relevance to SDG. First, our tools directly contributes to SDG 4, quality education by serving as an interactive learning platform. It helps students understand AI technology while teaching them to identify sport equipment. Next, we align with SDG 9, which is industry, innovation, and infrastructure, which focus on innovation and infrastructure. Our AI system demonstrate how simple tech solution and can optimize workflow, like smart inventory management in sport retails or training tools for athletes. Next. Next is the future improvement of our mini project.
Aku next slide. Now let's talk about the real world impact of our project. This system isn't just a technical experiment. It's designed to solve practical problems. As an educational tools, it helps people learn about AI while also familiarizing them with different sport equipment. Second, in retail support, adds shopkeeper in classifying inventory. Finally, for training aid, players or coach can use this tool to instantly identify the right equipment. Next, I will pass to Muhammad Fikri.
Okay, next is future improvement of our mini project. For future improvement, we can add image recognition using computer vision to allow photo-based classification. Next, we also can expand database to include more ball types and regional variations. Next, we can integrate with mobile apps for wider use. And lastly, we can add voice-based interaction for accessibility. Next is demonstration.
Here I do the demonstration. First, we get the data from the Kaggle dataset. This is the data we get. After that, we send to teachable machine to get the source code. Continue that, we use the Anaconda. What? After that, we change the TV. For this, I have two drivers, so it's different a bit. And then we run the program Python spot.py, and then we pick the figure to select the ball. For example, we pick football, American football, we get accurate confidence of 99. And if we pick another ball like basketball, we get the confidence on 99% on qualification of basketball. We also have a sample of from our camera. This, the one that I took, they classified as football with 99.1%. Continue that, we continue with the conclusion.
For the conclusion, The expert system is a simple, smart, and useful AI tool for identifying ball types. It shows how AI can be applied in real-world practical application. And lastly, with future enhancement, it has the potential to be scalable and widely used in both education and industry. Um, any questions, sir?
No question. No question at all. Because I already see the system. It just detect the ball, the type of ball, right?
Yes.
Without giving the suggestion. Okay, so I think that's all. Okay, so we proceed with the next group.
Okay,
Thank you
thank you,
very
sir.
much. Next group is group 24, Liana Afira, Nur Aisyah, Nurain Farahin. So I start the timer 10 minutes from now.
Assalamualaikum and good evening, Doctor. So our group will present our project titled Mushroom Detector. So firstly, I will introduce our group members. So firstly, my name is Norain Farahid.
My name is Liana Alvira.
It's Nur Aisyah. So now I will introduce our project. So the mushroom detector is an expert system that helps user determines whether a mushroom is poisonous or non-poisonous. So this system aims to promote safety, especially for foragers, hikers, or individuals that are unfamiliar with different mushroom species. So our expert system covers SDG3 and SDG4. So what is SDG3 and SDG4? For SDG3 is for the health and well-being, while for the SDG4 is for quality education. So our key features of this expert system are poison detections intelligence, wide uses of the high-risk mushrooms, and it is for educational aids. So our problem statements. So we know that mushroom consumption poses a serious health risk due to the difficulty in distinguishing between safe and toxic species. So there is a statistic about this. According to market scan data 2016 to 2018, 8.6% of the 556 patients who consume poisonous mushrooms experienced serious adverse outcomes. This highlights the real dangers and urgency of providing accessible tools for the mushroom identification. So without a proper knowledge or guidance, the public remains at risk of poisoning, hospitalization, and even death. So our objective, we have three. Firstly, we want to accurately classify mushrooms as poisonous or non-poisonous based on the mycology. Second, we want to enhance the public awareness and knowledge about mushroom safety through the educational features. And the lastly is we want to reduce the risk of the mushroom-related poisoning cases by providing real-time accessible guidance. Next, I will pass to Yana.
Okay, so in the slide, I provide the general forward chaining for the system. The system will analyze four characteristic of mushroom. That is texture, color, pattern, and shape. And then it will get the mushroom species. So based on the mushroom species, the system will provide mushroom details also. Okay, so continue with the system demonstration. So this is our system, mushroom detector. So our mushroom detector have two our mushroom detector can select image and also can capture image from the camera. So we choose select image first. So image from the laptop lah. So button. For example, we want to button mushroom. Okay, so the system detect the image is a button mushroom and the type in non-poisonous. So the user can safely consume the button mushroom lah because it is non-poisonous. It also give the description of the mushroom and also the habitat of the mushroom. So, for example, capture image from the camera. Okay, so it will capture image from the camera lah. So since we don't have a real mushroom with us, so I use Google Picture. Okay, so from the image that capture, the system detects it is fly agaric mushroom and it is poisonous. So since it is poisonous mushroom, it will give warning to the user to not consume the mushroom. So it will give description and habitat to the user also. So based on the details, user can have knowledge about the mushroom and learn about the mushroom habitat as to not consume the mushroom, the poisonous mushroom. So we continue to future improvement.
Okay, so there are some key areas we can focus on. So in the future, we can make our system even better by adding user history features. So user can review mushroom they have identified before. Next is provide first aid and emergency instruction if a poisonous mushroom is consumed by user. The third one is we could enhance the system to better recognize and filter out non-real image so that it only process actual mushroom photo accurately. And the last one is the system need to require faster runtime because improving runtime performance is to ensure the faster and smoother detection, especially in real-time use. So next is conclusion. So for conclusion, this system help user identify poisonous and non-poisonous mushroom more accurately, which can really improve safety, especially for foragers and the general public. And it also align with the need reduce poisoning case as highlighted by health data. And the last one is support safer consumption choices where expert guidance is available. And for the anticipated impact, the first one is improve safety. It will reduce mushroom poisoning incident by helping user make informed decision. The second one is educational benefit, which is raise public knowledge about mushroom species and danger. And the last one is accessible guidance, which is real-time detection provides immediate risk warning during foraging. So that's all from our group. Thank you.
Yeah. So I just want to know, so is this system able to categorize the mushroom type, right? So this system able to so that's mean want to know about the what kind of the expert system task that you want to replace. But I'm not so sure in real life we need to we need to we need to classify. I mean, there is a job that doing the classify the mushroom poison or not poisonous. I'm not so sure about that. If I'm not mistaken, if you go to the tak kisahlah Tesco, if you go to Eon shopping complex or maybe Mydin, if let's say they sell the mushroom, they sell the mushroom, so that's mean usually mushroom you can eat. There is no people that guiding the user or this mushroom is cannot eat, this mushroom can eat. So any mushroom that sell in the shopping complex, usually we can eat. Okay.
For this system, for our expert system is mycology. So, we built this system because there's a case there's a case where people would just pick out mushroom from the street and not knowing if it's can consume or not. So there's a case that they eat the poisonous mushroom.
Okay, so I think this all time's up. 10 minutes. Actually, I want to ask more, but you know, masa tu pendek. Okay, thank you very much. Okay,
Thank you, sir.
madam. Really sorry about that. Next time you kena present cepat-cepat so that kita ada masa banyak. Okay, so now we proceed with the group 25, Kensinger, Wo Chun Kiat, Jonathan, Rahizat. So I turn on the timer, 10 minutes from
Okay,
now.
hello, can anyone hear me?
Yeah, sure can.
Okay, hello, for our project, we are doing an eye disease detection. So for our group, we are Kesigan, Wong Chun Kiat, me, Jonathan, and Raizat. Next slide. So what is our system? Eye disease detection is a diagnosis tool that uses machine learning and computer vision to analyze medical images of the eye, like OCT scan, to automatically identify signs of diseases. Okay, next slide. So for the problems, in many rural areas, they have limited access to screening. Mostly the doctors with the expertise of checking eye, aka ophthalmologists. With this problem, it will cause more delayed diagnosis and cases undetected. And then also manual diagnosis limitations where they'll result in misclassified scans. As for our project, the SDG related is good health and well-being. Right, next slide. So why does this system matter? Because according to World Health Organization, there's a lot of people in the world that have vision impairment and they do not even know about it. So if we have this system, we can help people to check if they have this vision impairment, and we can address it early to prevent any more vision impairment cases. And next slide. So as for the scope and target users, we tested 3 eye diseases: cataracts, which is cloudy vision, light sensitivity, diabetic retinopathy, floaters, and then another vision problem, glaucoma, eye pain, halos around the lights. As for the target users, it is the doctors, these doctors that specialize on eye treatment, reduce time spent on manual screening on high volume clinics to improve workflow efficiency and solve problem of delayed diagnosis and undetected cases. Next slide.
So I will can everyone hear me?
Yes.
So I will present the system functionality. So this one is the user-friendly system that a user just simply upload the image, then they will see the result. So after they upload the image, the system will analyze and detect the eye disease and giving some cause of disease, the symptom, and treatment for it. So next. So there is 3 test metric. So accuracy, which means we test the system using the tested dataset, and generalization, we test the performance on some unseen dataset, and precision, which means we test percentage of correct positive prediction. So there is some challenge in when we using this teachable machine, like we insert more than around 4,000 data set, then it maybe take longer time to train the machine, and the input capability is limited to image only. Next. So for future improvement, we might expand more data set to detect the more eye disease like optic neuritis and retina blastoma. maybe we can partner with some hospital to get the more rarely eyes disease data set to train the machine. So I will move on to the next members.
Okay, before demonstration, the data that we got is from the Kaggle, which is here. There's about 4,000 data sets, but we only used about 100 for each type because if we took too much, it might take a lot of time to train it. And now we will be moving on to the demonstration of the coding.
Yes.
Right, so this is the system, eye detection system. So first of all, we need to upload the image. Once we have scanned, we can upload the image. There's around 100 image in each diseases. So this one is for cataracts. So it will scan the eye. Once they already scan the eye, it will put in the system and then it will detect for diseases. So here you can see the prediction is cataracts for this eye, and then the confidence level, and then the classification is risky condition. So over here in disease information, it gives what is cataracts. It's about a cloudy vision in front of your eye. And then it will show the causes mostly because of aging and also due to diabetes, injury, smoking, and long-term sun exposure. And then it also says the common age groups for over age of 60. And what is the symptoms? There's blurry and foggy vision. And what's the treatment for this disease, cataracts, which is surgery. And for pre-surgery, there's the medicine they have suggested for pre-surgery and then for post-surgery. So it also states the function of the medication to prevent infection, to reduce the swelling and inflammation. Similarly, for each diseases, once it detects, it will give the disease information. So it's easier for the ophthalmologist to advise the patients. So as usual, the disease is detected, and then it gives what is diabetic retinopathy. It's basically a disease you get in the eye based of diabetes, and then the causes is stated over here, and then the age group, over 5 to 10 years, people can get this also. What is the symptoms? Blurred vision, floaters, dark spots, trouble seeing at night, and sometimes vision loss. So what is the treatment for diabetic retinopathy? Eye injection, steroid implants, laser therapy, and it also gives advice to how to maintain with this disease, which is keep your blood sugar, blood pressure, cholesterol, and in an optimized level and maintain a really good diet. So similarly for glaucoma, which is also another disease for eye, which is also very famous. So over here in glaucoma is also a group of disease. It basically damages the optic nerve. So as we know, our eyes produce the fluid production. So this one blocks the eye drainage, which means the fluid from the eye doesn't come out. So this one said the common age group, which is risk after age of 40, the risk for this disease is highly likely. And what are the symptoms? No early symptoms, but gradually you lost the vision. And sometimes there's eye pain and then there's blurred vision in late stages. So this one is the treatment. You can use multiple eye drops to help you with the fluid drain from your eye. And then there's also surgery and laser treatment. So what if one of the patient, they upload they do the scanning, and then when they scan, they have no diseases. What will the system say? The system will give the report as healthy eyes is normal, and then it will say healthy eyes with clear lens and no visible damage or diseases. And then the retina is all properly attached. There's no cloudiness, no inflammation, and everything. So for the treatment, there's no necessary treatment for this eye, but in order to maintain, it gives advice how do you maintain a proper eye, the healthiness of the eye. So get yearly eye exams, eat foods with rich in vitamin A and C and E, avoid smoking, manage screen time, wear sunglasses outdoors to protect from UV rays. So this is the advice to maintain your eye, to maintain a healthy eyesight. So that's all from us, bro. From us, sir. Thank you.
Welcome. Thank you very much. Okay, so I think the system is good lah. Okay, because as you can see here, it have a suggestion. So the user can use the system without meet the real expert, so that it really helps the user.
Yeah.
Because if you want to meet the real expert, we need to queue, right? We
Yeah,
need to go
this
to
one helps
hospital. We need to
the
spend
user
the
to
spend the
get the
money.
information. Yeah.
Okay. And then okay, so that's all. Okay, I think that's good.
Right.
Okay, so we proceed
you,
with
sir.
the welcome. We proceed with
Thank
the
you,
next
sir.
group. Okay, the last group is the group 28, Amirul, Isaac,
Yeah,
Said
it is me.
Hani.
Yes.
So this is the
Can
last
you see the
final
slide?
group. Okay, sure. So I turn on
Okay.
the timer, 10 minutes.
All right. Assalamualaikum and good afternoon, everyone. My name is Amir Hafiz, and the other friends is Syed Hani and then Isaac Ryan. We're presenting about our introduction and implementation is expert system for the fruit and vegetable disease detection. So for the introduction, agriculture play a crucial role in our economy and health. However, manual inspection for the fruit and vegetable disease is quite slow for human and inconsistent. So for the large quantity, it will become more disaster, and it's rely heavily on a human observation, and which is vary between individual. That's where our projects come in. Using artificial intelligence, we aim to build a system that can detect disease in fruit and vegetable more accurate and efficiently. Our goal is for farmers, retailers, and even consumer for the quality controls, improving food safety, reduce waste, and boosting productivity through early and reliability disease detection. Next. To Syed.
Yeah, next slide. A problem statement in agriculture. Manual inspection is widely used to check fruit and vegetable diseases. However, it's inconsistent and it depends on human judgment. That's why early signs of diseases like mold or like discoloration are often missed or overlooked by the human eye. That's why we need an automated detection system, one that's fast and scalable. Next slide. Objectives and target users. Our main goal is to build a deep learning model that can detect whether the vegetable or fruit is healthy or rotten using images. This can automate quality control and reduce food waste and improve food safety. The target users are farmers, retailers, distributors, government agencies, and even consumers at home. Next. System design. Our system is based on a labeled dataset with 28 folders with 14 types of fruit and vegetables, each with healthy and rotten samples. And the interference engine, rule 1 is if the fruit or vegetable has dull color or mold spot. And 3 is if it has irregular shape or black patches and bruisings. 2 is if the fruit or vegetable have intact shape, bright color, since it's hence it's healthy. 4 and 5, it depends on the confidence level. If it's below or equal to 80%, it's going to be unknown, or it has parsing fails or unknown status. It's going to be failed. All right, next is Isaac.
Okay, so we continue with the system architectures. So we have four system architecture here. First is the user interface, which is UI, which is whereas we accept the manual input from color and textures, or we can also use the image uploaded. And we design it for farmers and retailers to interact with the system. It is easy to access. And second was the knowledge base, where is content level as the dataset, which are within 28 directories of healthy and routine procedures. And it is also included with the rules of rules for classification, such like the example just now cited. If milk, then it will be included in the rotten. The third one is the inference engine, which is accept manual inputs, such as we do have the color and textures or image uploaded based on it detect on the shape, colors, and spots. Last but not least, the output module, which is it's also display the result with confidence scores, such as example 100 healthy, and it is also suggests actions like we can save it in our file systems where you can keep the data in a file Excel like that. Okay, next. So based on our system, we have met all the benefit with which its accuracy is reliable disease detections and also the efficiency, save time for farmers and retailers, and it has also helped us to reduce the waste, such as early spoilage detection and scalability, adaptable smart farming system. And then for the future improvement for our system was, and the equipment that we have already gotten is the develop the functional AI system for this of classification, and also we have also been demonstrated potential to improve food safety and reduce waste. So we hope that in future, our enhancement will having a mobile apps for real-time detection and also having an integration with IoT device in smart farms. So we're going to the implementation or we call it as a demo. So I give it to my friends Amirul Hafiz.
For the implementation, I use we use Kaggle as our data set. Then we run the codes. Thank you. So for our system, we have three types of things like unknowns, healthy, and rotten. So for example, if we put like a example for unknown picture is a trash bin, then we indicate as an unknown, so we didn't detect which fruit is this. And then for the rotten, if we try to put rotten, then they say the here indicator is red, and then they say this is a rotten, and then the confidence level in 100. And then the top three prediction is to predict to predict what the stuff that we try to classify. And then the explanation say that it's poisonous, and then dispose, expect further, and then storage tip, dispose, help produce, and we put the additional notes, do not mix with healthy product to avoid contamination. And for example, for healthy products, so we become a green indicator, which means it's healthy, and then with the confidence level, and then with the times that we try to put our image, and they give you explanation and storage tip, additional with the top three prediction, additional notes. So we also include our features, which is start camera. This to put to say to detect the our system. Yeah, it took a lot of time because it's so laggy. It's laggy, yeah. Oh, it's not responding. Okay, so if I put the like banana here, then you will detect as a healthy, then it's indicate lah. If I want to put to disband the auto classify, so this disabled, then I can classify it also. We also put the save to CSV file. If we want to save this file, then we go to a file, then history, then they ask for banana. Our banana is here.
Okay, sorry for
Okay, that's all.
interruption. Okay, sorry to interruption Amirul. Ni yang
Sorry?
saya tak this thing that I not understand lah. So what the purpose of the you make the comment apa tu? Store in a cool dry pass
So in the code, because the item is
process.
fresh. So like so example, if we put a banana, so we need to put it in the cool, so it become more fresh. Or sometimes if you put tomato, then need to put in the refrigerator in order to make it cool. If we put outside, then the tomato will be spoiled easier.
Okay. Okay, may I know what is the SGD that you are targeting?
We take SGD 12 as a production.
12.
SGD
12
12
is
responsible
this
consumption
is
and
refer
production.
to?
Sorry?
12 is refer to?
Responsible consumption and production.
So how you can relate it with your system?
So with this, we can create a sustainable agriculture practice. So we detect if when you do a production, detect is it your amount of those production that last quantity, is it there is a spoil or not? So at least it's make it more efficient for resource lah.
Okay, so that's all for my comment because time's already 10 minutes. Okay, thank you very much, Amirul and the team member. So I think that's all for today lab session. So don't forget to submit your lab, the lab answer for at ULearn portal. Okay, because today we need to do also lab question, which is already upload at our portal. Okay, so don't forget also to fill up the attendance for today. Okay, so that's all. Thank you very much. Okay,
thank you, sir.
All right, thank you.
Thank you, sir.
Today is our final class. Okay, thank you very much.
Right, bye, sir.
Bye.
Thank you,
Sir,
sir.
Thank you, sir.
for the document,
Document.
so boleh bagi